factory pattern. This is basically a creational design pattern, and it is used to decouple the logic between how an object is created and how it is used. Creating an object is simple in most languages. It's like a simple new statement. So why do you need a complete design pattern for that? If it is only one object or two or three objects, then it is simple. But if there are many objects like 10, 20, 30, 40 objects, then it becomes cumbersome. And if some change happens in the creational logic, then we have to go and edit in all those 30, 40 places. To avoid that, we use factory design pattern. For example, you have the pieces in chess. There are totally 32 pieces. There are two kings, one of white, one of black, two queens, one of white, one of black, two knights each, 8 pawns of black, 8 pawns of white. There are multiple different pieces and there are total 32 pieces. So writing 30 overall logic for all these 32 pieces will be cumbersome. What we do is we have a piece factory which have a creational logic. It creates a piece object using the color of the piece and type of the piece. WK white king, WP white pawn, something like that. This will make it easier. Another example can be some sort of a computer car race game. All of the cars have the same method. They race. They have some sort of accelerate method. They have some sort of a image thumbnail image method which returns a 3D image which can move in the game. But implementation of all will be different. 3D image of a car four-wheeler will be different from that of a scooter or from a truck, or even 3D image of two different cars like a Toyota and BMW will be different. So you see, the methods will be same but the implementation will be different, and in these cases it is much better to use a factory design pattern to create them, so that at a later point of time, if you want to change it, we just have to change code inside that one factory class and not everywhere that particular car has been initialized. Let's see how it is used. Let's use the car example for seeing how a factory design pattern is implemented. There is a common interface which has the methods. It can be an interface or a superclass. It will have the methods which will be implemented by all cars. For example, here we have taken two methods, get price and get acceleration time. Every vehicle which wants to be a car will implement this interface. So Mercedes wants to be a car, it will have different values for price and acceleration time. Both are different type of cars, both will have return different values. And whenever the ID is equal to Mercedes, we return a Mercedes. Whenever the ID is equal to Range Rover, we will return a Range Rover. But tomorrow, let's assume a new type of car comes, an electric car, something like a BMW i7. What we do in that case? If we had not used a factory pattern and BMW still wanted to be a car, then we would have to go and change the implementation, or would have to add a parameter at every place a Mercedes or Range Rover is initialized. But we don't have to do it. What we do is we overload this getCar method, have it take two parameters, string ID and is electric, and that method will return a BMW if it is an electric. You see, using factory pattern has saved us from headaches of going and changing the creational logic everywhere whenever some sort of new parameter is added or changed. Let's see how we are going to use the factory design pattern in an actual interview question. We have the design chess game, and I have already opened the question. In a chess game, there are multiple different pieces, and this is the blueprint for a chessboard. You have got various white pieces in this side and black pieces in this side. These are all white pawns, white rook, knight, bishop, queen, king. And again, here we have black pawn, all these are black pawns, rook, knight, black bishop, black queen, black king, and so on. So how have we implemented it? Instead of an interface, the common functionality is in the class piece, which has this constructor piece and which have got moves, and this is the can move method which this class piece has. This class piece is implemented by different chess pieces, class king piece, knight piece, pawn piece. Other pieces are all created directly from the piece object. We will see how. Let's come to the chess piece factory object, which actually creates all the chess pieces. We will just see the create piece method. It takes two parameters. The first one is color and the second one is type. So the color is this WR. WR means white rook. So the first character is W, second character is type. R for rook, B for bishop, Q for queen. So how are the chess pieces created? This method returns the piece object, it passes the color and the type, and the move is created. The queen has got two moves, the straight move and diagonal move. Straight means both horizontal and vertical, and diagonal is like diagonal move. Rook has only got a straight move, that is both horizontal and vertical move. Bishop has got a diagonal move, and the rest of the three pieces, king piece, knight piece and pawn piece, have their own implementation. They are not created from the generic piece object. This is how the chess piece factory creates objects. Here we have returned null. Generally you refrain from returning null, you return some default object. Here the king, knight and pawn have got their own implementation for the can move method that we can see. This is how the pieces are created in a factory, and how all these are used. They are used from the chessboard method. Here a board of size row column is created, which has got the size of this whole blueprint, and then for each row and column we check if there is a piece there. It means there are at least two characters there, else it is empty. If there are two characters there, let's suppose WP is there, we will extract the color, that is the first character W, and the second character type, which is P, and then we will ask the factory to create us a piece and put that in that row column position of the chessboard. This is how overall the factory design pattern is being used to create all the different chess pieces in this, and this will make things simpler for us. Low level design game of chess is actually a very interesting question, because it uses two similar patterns, factory pattern as well as strategy pattern at the same time. Here we also get to look at how factory pattern is different from strategy design pattern, because if you look at the code, both these patterns look very similar. Both have got an interface or a class which contains the common functionality, and the other classes which either extend that generic class or implement that interface. We need to actually understand what is the real difference from it, else we get confused. People get confused most of the times. When you look at a design pattern, we have to look at it from two perspectives. First, why that design pattern is being used, and the second is how that is being used. Now, how is the code part, which is similar in case of both these patterns. Why factory design pattern is being used for creating multiple objects. There can be 8 pawns of white, 8 pawns of black, again 2 rooks of white, 2 rooks of black. You can see there are multiple similar or even same objects are being created, and all of them follow the same interface or have the same method in them. This is factory design pattern. But in case of the strategy design pattern, let's see how we have implemented it. We have the move interface, which was also there in the piece class. This move interface means whether a piece can move from a starting position to an ending position on the chessboard. We have classes which have implemented this move interface. We already saw the names of those classes. These are the classes: diagonal move and straight move. Diagonal move is made by bishop, and queen also makes this move. Straight move is basically your horizontal plus vertical move. It is made by queen as well as rook. These two are the moves. We have implemented the moves using only these two methods, and we have used these moves to actually create the chess piece objects as well. So we have basically combined strategy and factory design pattern, but the difference is in how these two moves have been used. Let's come back to the chess piece factory object. You will see that a single object of both these move classes are made, and they are basically reused again and again for creating different pieces. If you didn't see, you can see the same move object is being used to create the different pieces. This is the difference. If you want to just see the difference based on the implementation also, generally in a factory pattern there can be tens to hundreds to thousands or even tens of thousands objects can be created. For example, if it's a computer war game, then hundreds or thousands of soldiers can be created using the factory design pattern. If it's a text editor, there can be 10,000 to 100,000 characters in them, and there also we can use factory design pattern. But in case of a strategy design pattern, there will be hardly 3-4 different algorithms, and all of them will be reused. If you are creating new algorithms which have the same functionality, use this strategy. If you are using real world objects for the same functionality, use factory. This is the difference between these two. I hope you understand. If you want to take just one thing from this video, then remember that we should use factory design pattern when we want to create similar real world objects and they are having the same functionality. That is, they follow the same interface. That's it. This was about factory design pattern. I have created a 7-day plan for preparing for your low-level design interviews. You can access it on codezym.com/roadmap. This will help you prepare for your LLD interviews efficiently. It has got short videos on a day-to-day basis, and on each day there is a practice problem. Basically, when interviews are scheduled by the recruiter, there is very less time. People are confused which videos they should see or what they should read and what questions they should practice, because there is tons of content on the internet, lots of videos on the YouTube, and time is of the essence. So here you have got all at one place, the theory as well as the practice part, and so your interview preparation will be smooth and much, you can say it's a smart way to prepare. So do give this a try, and I wish you the best of luck for your preparation. Thanks for watching this video. Bye.